This is the solution to problem 5.108 in Munson's book. This problem asks to find the energy lost in a bend, and also in part B, energy lost from the jet of water from exiting the nozzle to coming to rest at some point farther. So the information that we need to solve this problem is provided in the figure, and also the control volume is given as well. So considering the control volume shown with the dotted blue lines, we call section 1 before the elbow or the bend, and then section 2 after the second elbow. So it's a 180-degree turn. The pipe itself is 12 inches in diameter, but the jet or the nozzle is 6 inches in diameter. The pressure at which the water is flowing into the system is 15 psi at a velocity of 5 feet per second. And what we are supposed to find out is what is the head loss in this system. Now, going back to the energy equation, that's what we will be using, which is based upon the conservation of energy. That states that the head at section 1 must be equal to head at section 2 plus any head added by the shaft work or subtracted by shaft work, so pump or turbine, plus any head losses that happened in the system. So clearly in this case, shaft head would be 0 since we have no pump or turbine, and we are trying to find HL. So HL will be equal to H1 minus H2. And we know that H is equal to the static pressure head plus, it's the total head, it's the sum of static pressure head plus the dynamic head or the velocity head plus the elevation head. So this can be simplified to P1 minus P2 over gamma plus V1 squared minus V2 squared over 2G plus Z1 minus Z2. Now, as you can see, this is an XY plane, so Z component is coming out of the paper. So both Z1 is equal to Z2, so this is equal to 0. The jet is coming into the open space, so P2 is atmospheric pressure. That is equal to 0. And everything else is given, so the head loss can be computed as 15 psi, and we have to convert this into PSF by multiplying it with 144 divided by gamma of water, which is 62.4, plus V1 squared, which is 55, and minus 5 squared minus V2 squared, and we don't know that yet. We need to find that, divided by 2 times 32.2. Now, to find the V2, we can use the continuity equation. We know that A1 V1 should be equal to A2 V2 for the incompressible fluid in this case, and A1 is pi d squared over 4, so in this case d is 1 foot, so 12 over 12 squared divided by 4 times V1, which is 5, must be equal to pi times the diameter squared of the outlet, which is 6 over 12 foot squared divided by 4 times V2. And by solving this, you will find out that V2 is equal to 20 feet per second. So now we can plug V2 equal to 20 feet per second. 20 squared, which gives the head loss as 28.75 feet. Now this is given in terms of the height of the in terms of the head, or the units of height. In order to find the energy lost per unit mass, we multiply this with G. So the energy delta E lost would be equal to G times HL, and that comes out to be 926 foot-pound per slug. So this is the answer to the first part of the question, which asks for the energy lost due to the 180-degree bend. I will clear part of this screen to solve the second part of the problem. The second part talks about the part after the jet has come out and to the point where it comes to rest. So we have a different cross-section control volume to deal with this problem. So let's call the point where it comes to rest as 3. So this will change our equation, energy equation. We can write this as energy or head at section 2 is equal to head at section 3 plus shaft head plus head loss. Of course, again, shaft head is 0, and we get head loss as H2 minus H3. And we can write this as P2 minus P3 over gamma plus V1 square V2 square minus V3 square over 2G plus Z2 minus Z3. Again, Z2 minus Z3 is 0. Now notice that in this case P2 and P3 both are atmospheric pressures, and they're both equal to 0, so this term goes to 0. And then final velocity V3 is equal to 0, so this term is equal to 0. So the head loss is whatever energy it came, or whatever head it came out with, is going to be lost by the end, which makes sense that it comes out to be V2 squared over 2G, which would be 20 squared over 2G, and this value comes out to be 6.21 feet. Again, this can be converted into energy lost per unit mass by multiplying with G, and this comes out to be 200 foot-pound per slug.